Hello students, good evening. So welcome to the session 4, rotational motion, system of particles and rotational motion. So already previous 3 sessions we talked about the center of mass, center of gravity, what is the significance of center of mass, significance of center of gravity. அதெல்லாம் நம்ம கவர் பண்ணிருக்கோம். Okay. இப்போ என்னன்னா we are going to start discussing about the rigid body motion. Okay. But the rigid body motion போறதுக்கு முன்னாடி we will try to just do a quick review of the angular motion. Okay, see already nama circular motion patti we have been talking about it. 2D motion adila we discussed about the circular motion and madri when we talked about the Newton's laws of motion adiliyum we talked about the circular motion, the centripetal force requirement. Even in the work energy theorem chapter also we talked about the circular motion, particularly that vertical circular motion. Okay va? So if we will try to understand what is the basic idea of angular motion, and when we want to understand about the rotational motion of the rigid body. Okay, so when you want to understand about the rotational motion of a rigid body, right, adukku the basic understanding of the angular motion that will be required. So the angular motion oda oru special case the circular motion. Circular motion enna theriyuma, it's a special case of angular motion. Okay, first angular motion enna, what is this idea of the angular motion? Adukku enna we will start with a very basic example paranga. Okay, so let us say there is a family of 3 people. There is a father here, mother and the son. Okay va? So this is a very simple example that will help us to understand the idea of the angular motion. Okay, if let us just look at the situation where this sun is moving on that straight line mela. Okay va? So he is step by step moving. Okay, so what is happening starting from here, right? So is the sun initial position, angle he is going to that final position. When the father is studying the motion of the sun, right, how he will talk about the displacement, he will talk about it, and he will talk about the velocity, and he will talk about the acceleration. These are all the linear motion parameters. Adana displacement, velocity, acceleration, what is it? Linear motion. So when he is seeing the motion of the sun, right, he will see the linear motion. So he will try to talk about the displacement, he will try to talk about the velocity, and he will try to talk about the acceleration. But when the mother is trying to study the motion, right, so boy at a position, let's say the position vector ane solala, position vector of the boy. Position vector anedi the line joining the reference. So reference is the mother, right? Angle we are drawing a line to the position of the boy. That is what we call as the position vector. Initially the position vector is there. When the mother is seeing the motion of the boy, right, so after some time he is going to this place, means she will see that the position vector is changing. So what is the measurement that she can think of? She can think of the angle covered by the position vector of the sun. So mother எப்படி அந்த motion visualize பண்றது, she will think of it like what is the angle covered. இப்ப பாருங்க, when he is finally at that final position right, இங்க பாருங்க, so she will see that okay, this is the total, என்ன தெரியுமா, she can call it as angular displacement and சொல்லலாம். So same motion, father is seeing the motion of the boy like linear motion, but mother case la enna, she is able to see the motion of the boy like what, angular motion. So motion when it is represented by using angles, right, adha nama angular motion study nu solluvom. Okay, so what is angular motion study? When you are able to, for normal linear motion nu sonna, we are able to measure the motion by using displacement, velocity, acceleration and the madri. If we are able to study the motion by measuring the angle, right, that is what we will be calling as the angular motion. Okay va? So in the idea nam ketta irundha podum. This is what is the general discussion of the angular motion. So whenever there is a movement, right, we can study the motion by using the angle covered. Okay va? So idoda special case enna pathina, that is the circular motion. So one of the special case of the angular motion is the circular motion. Inga parunga, here in circular motion, right, the reference is the center of the circle. So center of the circle nama reference vechi we will try to see. Inga parunga, the particle from point P landi it is going up to P dash. So the position vector of the point, right, is covering how much angle? Delta theta. So ingena theriyuma, this delta theta we will be calling it as what, enadi, angular displacement and solluvom. What is the delta theta going to be called as? Angular displacement. Idoda SI unit enna? Radians, because plane angle will be measured in terms of what? Radians dana. So when you look at a particle which is going in a circular path, right, that is a special case of angular motion da. We can study the motion of the particle by using what? The angular displacement concept which we can talk about it. Okay, but normal displacement and sonna we define, see, normal displacement is what? It's a vector quantity dana. Normal displacement and it's a vector quantity. So what about this angular displacement? Will it be a scalar or a vector? So when you are looking at the circular motion, right, adukku rendu possibilities irukka. Onna paranga, this is like what? Inga paranga, what is this? Idanade, this is the clockwise dana. Inga paranga, what is this one? It is what? Anti-clockwise. So nama circular motion of an particle patha, you can have it clockwise illana anti-clockwise. Appo enna theriyuma, the angular displacement when the particle is going clockwise, it has to be different from when the particle is going anti-clockwise. Adanal angular displacement is also defined as a vector quantity. It is defined as what? Vector quantity. So angular displacement is not a scalar, it is what? It is a vector quantity. How do we give the direction of that angular displacement? Eppadi theriyuma, inga parunga. So you just have to curl the fingers in the direction of the particle. So whatever way parunga. So for example, this is the clockwise. Clockwise la, if you are curling your fingers, right, thumb or direction eppadi irukum? Thumb will be pointing into the board. So that will be the direction of the angular displacement. That is the direction of the angular displacement. And the bakka parunga, when it is going in the anti-clockwise, when you are curling your fingers anti-clockwise, right, up and the thumb will be pointing out. Okay, into pota, that is going into the board madri. If you put a dot means that will be what? Coming out. So that will be the direction of the angular displacement. So how do we represent the direction of the angular displacement? By the way in which we will curl our fingers. Okay, so if we curl your fingers depending upon whether the clockwise or anti-clockwise, thumb indicates what? The direction of the angular displacement. So oru vishayam namakku naamu vechinu enna theriyuma, the angular displacement will be always perpendicular to the plane of the circle. Paranga, either going into the plane or coming out of the plane, it will be always what? Perpendicular to the plane of the circle. Okay va? So in use paranga, there will be only two possible directions. One is what? If you are curling in clockwise means thumb will be into. anti-clockwise curl panna, thumb will be what, coming out of the paper or out of the board and madri. Okay va? So this is how we are going to represent the angular displacement. Okay, in case of the normal linear motion, again we'll talk about what is the rate of change of displacement. That is what is our velocity, right? What is it? That is what is the velocity. But before we go to the velocity rate, I'm going to point another. Generally for the vectors we'll put a bar. For the angular motion or circular motion, these vectors, right, either we put a bar use panla, illana we can put a dot. That is another notation, and the symbol you just put a dot that represents what we are talking about, the angular displacement. Okay va? So this is how we will see the vector representation of the angular displacement. Okay, when we are looking at the linear motion, we will talk about the velocity. So velocity and sonna adukku rendu vidhamana definitions varum. What is it? One is the average concept, rendavadhu instantaneous. Appadidana? So we have average value and instantaneous. Average and sonna, what is it? The displacement by time taken for a finite time interval. Appadidana? Instantaneous means for a small time interval dt. On the time interval kulla we will see what is that small change in displacement, differential element and so that will give us what is the instantaneous velocity. The angular velocity rate will be represented by omega, but we will put either omega dot or omega bar. The representation of the angular velocity will be given by what? Omega dot or omega bar. Okay, we can define average angular velocity, and we can also define the instantaneous. So average and let's say for example for a delta t time, the angular displacement is delta theta. The average value of that angular velocity will be what? Delta theta by delta t. This is the average value. Okay va? Instantaneous and so now what we need to do? Instantaneous, right? What is it going to be? We'll take a very small time interval dt. On the time interval kulla, let us say the angular displacement d3 then omega will be equal to what? D theta by dt. Adilandi we will be able to get what is the instantaneous angular velocity. When we talk about the direction of this velocity vector, the velocity will be in the direction of the displacement vector. Because velocity is equal to what? Displacement of time taken. The direction of the angular velocity rate will be in the direction of angular displacement. So in the direction the angular displacement is go, same direction the angular velocity also will exist. Same direction is already in the direction we talked about it, right? The direction of the angular displacement will be what? Perpendicular to the plane of that circular motion. Either it will be coming out or it will be going into the plane of the circular motion, depending upon whether the displacement is clockwise or anti-clockwise. Okay va? So what will be the SI unit of the angular velocity? Angular velocity SI unit it is what? Angular displacement divided by the time taken. What is it? Angular displacement divided by time taken. So what is it going to be? Angular displacement and sonna adha SI unit radians. So the SI unit will be what? It will be radians per second. What will be the SI unit of the angular velocity? It will be what? Radians per second. Okay va? But sometimes we'll have one more unit for the angular velocity. Like normally in case of speed or velocity also, right? We know that SI unit is what? Meter per second. But over some cases they will give us the speed or velocity in terms of kilometer per hour. Now we should be converting it into, so wherever it is required we will be converting it, right? We also have one more unit for the angular velocity, which is revolutions per second, or more particularly revolution per minute and solita. What is it? Revolution per minute. This is what is also represented by the symbol RPM, revolution per minute. Revolution enna theriyuma, ingala start pannittu, if it is covering one full circle, that is what we call as one complete revolution. So one complete revolution and sonna, what is it? RPM, revolution per minute, means one revolution means what? 2 pi radians. And because the angle in a full circle is what? 2 pi radians dana. Divide by minute means what? 60 seconds. What is it? 2 ones are 2 30s are. So 1 RPM will be equal to what? Pi by 30 radians per second. This is the multiplication factor. 1 RPM evala? Pi by 30 radians per second. Okay, wow. This is about the units of the angular velocity. This is about the units of the angular velocity. Because we already talked about two physical quantities. One is the angular displacement. Rendavathu angular velocity. Okay. So when we talk about the angular displacement or angular velocity, the other question, the unit patti nama discuss pannirukom. The other question that will come to us is what will be the dimensional formula. So angular displacement and sonna, that is representing by what? It is represented by the plane angle, which is the radians. Okay, it is represented by the plane angle radians. Remember, plane angle and solid angle, those two are what? Supplementary physical quantities. Adanal they will not be having any dimensional symbols. Now the 7 fundamental, right? Only the 7 fundamental will have the dimensional symbols. Supplementary physical quantities, the plane angle as well as solid angle, adukku dimensional formula, dimension symbol kadiyadu. So angular displacement, right, will be dimensionless. Because this is representing the plane angle. Okay, wow. But what about the angular velocity? Angular velocity is what? The angular displacement. This is radians per second, right? Numerator radians means dimension kadiyadu, 1. Denominator second means what? Time dana, which is what? Capital T. So the dimensional symbol or dimensional formula for the angular velocity another paranga t power minus 1. What is the dimensional symbol or dimensional formula for the angular velocity? What is it? T power minus 1. Okay, wow. So this is about the angular displacement and angular velocity. Now we look at one important result, the angular velocity and linear velocity relation. And what is it? The relation between the angular velocity and linear velocity. Okay, so again we will just try to take a particle which is going in a circular path. Okay, wow. We are looking at a particle which is going in a circular path. For a time dt, differential time interval. Okay, wow. And the time interval kulla, let us say that angular displacement another d theta. Okay, wow. The radius of the circular path is r. What is the omega value? D theta by dt. Equation 1. The linear displacement ds will be given by the length of the arc. Linear displacement is given by what? Length of the arc. The angle is d theta, right? So length of the arc on sonna, what is it? R into d theta. What is the length of the arc? Circular radius multiplied by the angle dana. So the linear velocity v is what? ds by dt, which is equal to, what is d theta by dt? Omega. So the relation in the linear velocity at any given instant of the particle which is going in the circular path is equal to what? R times of omega. What is the relation? V will be equal to what? R into omega. So omega will be equal to what? V by R. Omega will be equal to what? V by R. Okay, wow. V is equal to R omega and so R omega will be equal to what? V by R. This is the relation between the linear velocity of the particle in circular path. The direction of the linear velocity will be what? Always along the tangent. In the relation, so if direction of the linear velocity, we have to draw a tangent. We have to draw the tangent. Always the direction of the linear velocity rate will be in which direction? Tangential direction. Okay, and what is the relation between the linear velocity and the angular velocity? V is equal to r omega. Okay, like the way in case of the linear motion, right? We'll talk about the acceleration. Define average concept, instantaneous concept. Average and sonna, what is it? Delta V by delta T. We can write it like also what? V minus U by T. V is the final velocity, U is the initial velocity divided by the time interval. Instantaneous means what? Small differential time interval. What is the rate of change of velocity? That is what is the instantaneous acceleration. Okay. So, angular acceleration. So, angular acceleration will be defined by using what? Using the angular velocity. Angular acceleration will be defined by using what? Angular velocity. Define same two ways. The average formula, instantaneous formula. Average is what is it? Change in the angular velocity delta omega by delta T for a time, measurable time interval. Instantaneous and what is it? For a differential time interval dt, and the time interval d omega is the change in the angular velocity. So d omega by dt, right? That is what? The instantaneous angular acceleration. Okay, so angular acceleration, right, will be what? Either the average concept or an instantaneous concept. Okay, like in case of the linear motion, right, based upon the acceleration or the value, we classify the motion. We'll classify the motion into what? Uniform velocity motion and sonna. Velocity will be what? Constant. Uniform acceleration motion and sonna. Acceleration will be constant. Retardation and sonna. The velocity will be decreasing. And based upon the acceleration value based panni, we classified the motion. Like, if the alpha is the symbol for alpha bar and sonna, or we can put alpha dot. Alpha is what? The symbol for the angular acceleration. If alpha is equal to 0, that represents what? Uniform circular motion. So uniform circular motion, what is it? The omega value will remain constant. Because alpha is 0 means what? Omega must remain constant. Omega is constant means the speed value, the direction of the motion keeps changing, right? But speed is given by what? V is equal to r omega, right? Omega is constant means V will be also constant. So the speed of the particle in circular motion will remain constant. Other than uniform circular motion. So uniform circular motion, alpha will be equal to 0. Alpha 0 means omega will remain constant. Omega constant means what? The object or the speed will remain constant. Direction of motion keeps changing. We are not saying velocity remains constant. Okay, where on the speed value it will be remaining constant. That is what we call as the uniform circular motion. Other than accelerated circular motion. So alpha will be what? Positive. Two possibilities. Alpha will be in the same direction as the omega. That is what is the acceleration motion, right? That is what is the acceleration motion. Okay. So omega value will keep increasing with time. That is the accelerated motion. What is the other possibility? Retarded circular motion. Retarded means what? Alpha we take it negative. Alpha we take it what? Negative. Okay. Omega will be decreasing with respect to time. So like the way we do in 1D motion, the angular displacement, angular velocity and angular acceleration, all of them, right, they have only two possible directions. If you are having a circular motion of a particle, if you are having circular motion of particle, right, we have only two possible directions. What is it? Coming out of the plane, or going into the plane, or into and pota, this is what? Into the plane. Okay, into and pota, this is the into the plane. Okay, so going into the plane, or dot and pota, what is it? Coming out of the plane. So these are the only two possible directions. அதனால என்ன தெரியுமா, like the way we do in 1D motion, அப்படியே அந்த sign convention base பண்ணி we will be able to solve the questions. If one direction நம்ம positive எடுத்தா generally என்னது, the direction of initial omega I ன்னு சொல்லலாம், that will take it as positive. All the quantities which are in பாருங்க omega I initial angular velocity is coming out of the paper ன்னு வெச்சுக்கோங்க, or coming out of the plane. That direction will be taken as what, positive. அப்ப இது into the paper will be taken as negative. Okay va, that is the sign convention. Like நம்ம இந்த 1D motion ல யூஸ் பண்ண மாதிரி we can use it here also. This is what the way we will classify the circular motion into the uniform circular motion ன்னு சொல்லலாம், or the accelerated circular motion, or the retarded circular motion. Okay va, இன்னொரு relation வருது, the relation between the angular acceleration alpha and tangential acceleration. The relation between what, the angular acceleration alpha and tangential acceleration. Okay, so what is the tangential acceleration? What is it? If you are looking at a particle going in a circular path, the acceleration rate, we talk about two types of accelerations. One is the acceleration that will be responsible for the change in the direction of motion. The acceleration responsible for the change in direction of motion. What is the name that we give for it? Centripetal acceleration. Second, the acceleration that will be related to the rate of change of the speed, which is what, dv by dt. This is what is the tangential. This is the tangential acceleration. Okay, so we are looking at what, the relation between the angular acceleration alpha and the tangential acceleration. What is the tangential acceleration formula? dv by dt. dv by dt and sunna derivative of v. Derivative of v is equal to r omega dana. R அப்படியே கான்ஸ்டன்டா இருக்கும். So r வெளிய வந்தா what is it, d omega by dt. What is d omega by dt? Alpha dana. So tangential acceleration எவ்வளவு, r into alpha. So for a particle which is in circular motion, tangential acceleration oda value, right, what is it? It will be equal to what, r into alpha. Okay va. Check பண்ணுங்க இந்த derivation. Okay va. So what is it? The relation between the tangential acceleration and the angular acceleration. Okay, so tangential acceleration at will be equal to r into alpha. So in case of the uniform acceleration, right, like in the case of kinematics, if acceleration is constant vechkonga, we had these equations of motion. V is equal to u plus at, s is equal to ut plus half at square, v square minus u square is equal to as. Displacement in the nth second formula, Sn is equal to what, u plus a by 2 into 2n minus 1. This is derived result. What is it? The displacement is equal to what, v plus u by 2 into t. v plus u by 2 means that is the average velocity into t. Okay va? So what is this? These are all the equations of motion in case of the uniform acceleration. In case of uniform acceleration, these are the equations of motion. Okay, so we'll have to use these by following the sign convention, like vertical straight line motion or the horizontal straight line motion. We follow the sign convention. Adu base panni we will be using these equations. Appadidana as it is. Era neenga indha relations paranga, the u adukku inga analogous ah enna varum, omega initial, v omega final, anga enna we have acceleration, inga enna varum alpha, time rendithilum same da. In case of the displacement there, inga enna varum theta varum, theta nu solla, or we can say delta theta, whatever it is. Okay, so theta or delta theta, whichever symbol we are using. So all these are what analogous notations. So in case of the linear motion la, what are we having? Initial velocity u, final velocity v, acceleration a, displacement s, adella varum. Inga enna we are having the angular displacement, and madri the initial angular velocity omega I, final angular velocity omega f, acceleration sonna angular acceleration alpha, adukaprom time will be same in both the cases. Ipo enna theriyuma, we are going to get exactly similar relations. Derivations pannadhu kediyadu, but we are going to get what? Exactly similar relations. What will be the relations? Angana we are having v is equal to u plus at, right? So inga enna theriyuma, omega final will be equal to omega initial plus alpha t. But oru vishayam enna, this will be only for the uniform alpha. And the case la mattum dhaan nama indha result use panna mudiyum. Like the way angana theriyuma, only for the uniform acceleration appada in the equations of motion nama use pannala. Inga appadha only when the alpha is uniform, right, we can use these equations of motion in angular parameters. Ipo parunga, displacement inga enna parunga, s is equal to what? ut plus half at square. As it is namaku varum, what is it? Theta will be equal to omega I into t plus half alpha t square. Inga enna parunga, v square minus u square is equal to a as dana. So inga parunga, omega final square minus omega initial square is equal to what? 2 alpha theta. Adutha sn, adukku equivalent enga varum? Theta n. Theta n is what? Displacement in the nth second is equal to what? Omega I plus alpha by 2 into 2n minus 1. And the result paranga, this is the displacement, average velocity into time. Adukana equivalent enna varum? Angular displacement is equal to what? Angular velocity average value into the time. In the result ella neenga note panikonga, because in the equations base panni we will be able to get questions even past year neatly on it. Okay, so as it is, anga eppadi whatever the equations we have, right, between u, v, a, t and s, as it is in equations varum. When we can use the equations eppo use pannala? When the alpha value is constant or uniform. Like anga when the acceleration is uniform, right, appoda nama the equations use panna mudiyum. Same way here also, when the alpha is constant, when it is a uniform alpha for that circular motion, the equations of motion nama use pannala. These will be what? Exactly analogous. Analogous nu sonna, as it is anga endha term varudho adukku equivalent term inga varum formula la. Okay va? So all these are called as what? The equations of motion for the ஓகேவா? So பாருங்க, we'll start with some questions. A particle moves in a circle of radius எவ்வளோ 0.5 meters. 0.5 சொன்னா what is it? That will be 4 radians per second வரும். ஏன்னா 2 by 0.5 means அது என்னது 4. அந்த மாதிரி final speed எவ்வளோ 4 meter per second. So the corresponding omega final எவ்வளோ பாருங்க 4 meter per second, same V by R formula 0.5 அது என்னது 8 radians per second வரும். ஏன்னா SI unit of omega என்னது radians தானா. So time is what 4 seconds. So they're asking us what is the angular acceleration. Angular acceleration சொன்னா what is the formula for alpha? Omega final minus omega initial by t அதுதானா. So 8 minus 4 by t is 4. பாருங்க what is it? 1 radians per second square. Check பண்ணுங்க what should be the answer. It must be what? Same. நம்ம எங்க அந்த மாதிரி like you know in the kinematics ல நம்ம எப்படி using UV S A time as it is, right? We'll have problems, but ஒரே ஒரு difference என்னன்னா all these will be in terms of the angular parameters. So as it is நம்ம எப்படி ரிலேஷன்ஸ் இருக்கோ அந்த மாதிரி நம்ம ரிலேஷன்ஸ் இங்க யூஸ் பண்ணலாம். Okay, good Maithili. So அதுக்கான ஆன்சர் என்ன? What is it? 1 radian per second square. So இந்த மாதிரி questions we'll be able to expect in the NEET examination. அடுத்த question பாருங்க. The angular speed of a particle which is in circular motion. So இங்க என்ன தெரியுமா? The angular speed ன்னு சொல்றாங்க. So angular velocity ன்னு சொல்லிட்டு we define. But what is the angular speed? Like the way in case of the linear motion, right? We will use the velocity ஓட magnitude மட்டும், இந்த டைரக்ஷன் எடுக்காம வெறும் அந்த magnitude மட்டும் நம்ம எடுத்தா what do you call it as speed ன்னு சொல்லுவோம். அதுதானா? Same way here also. The angular speed ன்னு சொன்னா we are just looking at the value of it. ஓகேவா? The angular speed of the particle in circular motion is increasing from 1200 rpm ல இருந்து 3120 rpm in 16 seconds. So 16 seconds குள்ள it is increasing from where 1200 rpm ல இருந்து up to 3120 rpm. rpm means what? rpm is what? Revolutions per minute. ஓகேவா? rpm என்னது revolution per minute. So அதுக்கான கன்வர்ஷன் இருக்கு நம்ம கிட்ட. What is the conversion? 1 rpm is equal to what? Pi by 30 radians per second. Okay. What is its angular acceleration, assuming that the acceleration to be uniform? So first என்ன கேக்குறாங்க? Angular acceleration value. Okay, so alpha formula enna? Omega final minus omega initial by t. அதுதானா? So இப்ப என்ன பாருங்க, the omega values are given in rpm. அது எப்படி நம்ம radians per second கன்வர்ட் பண்றது? Just multiply by pi by 30. Pi by 30 வச்சு நம்ம multiply பண்ணா that will be converted. அவ்வளவுதானா? So 3120 into pi by 30 minus 1200 into pi by 30. ஓகேவா? Divided by time எவ்வளவு பாருங்க 16. So this is our alpha value. Simplify பண்ணி சொல்லுங்க. இத அப்படியே நம்ம simplify பண்ணா we will be able to get what? The alpha value வரும். Check பண்ணுங்க what is the alpha value. So இங்க பாருங்க 10 cancel ஆயிடும். அதுக்கப்புறம் 3 ones are 3 104s. Okay, இங்க பாருங்க what is it? 340s are 1200 தானா? So 104 minus 40 means அது எவ்வளோ 64 So 104 minus 40 என்னது 64 தானா? So numerator என்ன 64 pi by denominator 16. So பாருங்க what is it? 4 pi radians per second square. And the pi அப்படியே இருக்கட்டும். So we don't need to simplify that pi value. So what is the answer for this? 4 pi radians per second square. Check பண்ணுங்க what is the answer that we must get? 4 pi radians per second. Good Aditi. Okay va? So second part of the question பாருங்க what is it? How many revolutions does the particle make during this particular time? இருக்கிற டைம்ல what is the number of revolutions made? இப்போ என்ன தெரியுமா? எப்படி how do we calculate the number of revolutions? How do we calculate the number of revolutions? சொல்லுங்க how do we calculate number of revolutions? The number of revolutions calculate பண்றதுக்கு நமக்கு என்ன தேவைப்படும்? We will be requiring the angular displacement தானா? Theta. Okay. So theta எப்படி? What is the value of theta? Theta formula என்ன? Theta is equal to இப்போ தான நம்ம பார்த்திருக்கோம். What is it? Theta will be equal to what? Omega initial plus omega final by 2 into t. ஞாபகம் இருக்கா இந்த result? What is it? Average angular velocity into the time taken. Average angular velocity into the time taken. Omega initial plus omega final by 2 into t. இப்போ பாருங்க what இதுல இருந்து என்ன வரும்? Omega initial எவ்வளவு? This is 1200 into pi by 30 பண்ணா what is it? That is 40 pi. அந்த மாதிரி omega final எவ்வளவு? 104 pi. இப்போதான் நம்ம பண்ணது what is it? 104 pi divided by 2 into time எவ்வளவு? 16. ஓகேவா? So இங்க பாருங்க what is this? 40 plus 104 means 144. So divide by 2 பண்ணா it will be what? 72. So பாருங்க 72 pi into 16. இது எந்த யூனிட்ஸ்ல வரும்? It will be coming in terms of the radians. And then it will be coming in terms of the radians தானா? So this is our this is the angular displacement in terms of the radians. Okay, but நமக்கு என்ன வேணும்? We are looking for what is the number of revolutions made. பாருங்க the angle covered ஒரு revolutionல what is the angle covered? 2 pi தானா? So number of revolutions made n ன்னு சொல்லலாம். N will be equal to what? The angular displacement divided by 2 pi. எப்படி வருது? Because in one revolution, right, it is covering angle 2 pi தானா? So whatever the angular displacement radians ல வருது, what is it? 72 pi into 16. Okay வா? So this angular displacement 72 pi into 16 அப்படியே நம்ம அந்த 2 pi வச்சு டிவைட் பண்ணா we will get what? The number of revolutions. பாருங்க pi pi cancel ஆயிடும். 2 ones are 2, 36 are. So அவ்வளவுதான் 36 into 16. Check பண்ணுங்க what is it? 36 into 16. That will give us what is the number of revolutions. Check பண்ணுங்க what is it? 16 6 எவ்வளவு? This is 96 9 அப்படியே இருக்கட்டும். 16 3s are what? 48. 48 plus 9 means 57. Good Maithili and Aditi, good. Okay, so இந்த மாதிரி questions வரும். As it is, right, நம்ம அந்த kinematicsல எப்படி இருக்கோ equations as it is equations இருக்கும். பட் ஒரே ஒரு என்னன்னா these are all equations in terms of the angular motion parameters. Okay, இன்னொரு விஷயம் என்ன? We will be able to use them when our alpha is constant. அந்த ஒரு particular caseல தான் நம்ம இந்த equations யூஸ் பண்ண முடியும். ஓகேவா? So அடுத்து பாருங்க, this is another important result. ஏன்னா I remember telling you guys the Newton's laws of motion chapter ஆகட்டும் or even in the work energy theorem, we said centripetal acceleration and value, right, is equal to v square by r and சொல்லிட்டு. I told you that no, we are going to derive it when we talk about the angular motion. So the derivation நம்ம பார்க்க போறோம். What is it? The centripetal acceleration and value, right? What is the result that we use there? V square by r and சொல்லிட்டு we have been using it all this time, right? but அதை நம்ம derive பண்ணலாம். So இப்போ அந்த derivation நம்ம பார்க்க போறோம். So what is it? Centripetal acceleration ஓட value பாருங்க. Centripetal acceleration ன்னு சொன்னா what is it? This is responsible for the change of direction of motion. என்னது? This is the acceleration responsible for the change of எதுக்கு responsible? Change of direction of motion. இப்போ பாருங்க, we are marking a point. ஒரு பாயிண்ட் மார்க் பண்ணா அங்கிருந்து we are just looking at a very close by point. Angle is changing by theta. Theta is a very small angle. ஞாபகம் வச்சுக்கோங்க, theta is what? Small angle. Okay, இப்போ பாருங்க, let us consider the radius of the circle எவ்வளவு r. இப்போ இங்க இருக்கிற velocity என்ன? v. இங்க இருக்கிற velocity என்னது? v. Because we are only considering that the angle is a very small angle, அதனால the velocity value will not change. அது அப்படியே இருக்கும். So only we are looking at what? The change of the direction. Only we are looking at what? The change of the direction. Okay, இப்போ பாருங்க, when the position is changing by theta, right? அப்ப என்ன தெரியுமா? The angle between the velocities also will be changing by what? Theta. பாருங்க அது எப்படி representation வரும்னு சொல்லிட்டு. So if the initial velocity v is like this, right? Once you change the position by theta, அப்ப என்ன தெரியுமா? இங்க பாருங்க, in the tangent direction and original tangent, அந்த ரெண்டுக்கு நடுவுல what will be the angle? It will be theta. The angle between both the tangents will be what? It will be what? Theta. So whatever is the angular displacement and சொல்லலாமா? Whatever is the angular displacement, that will be equal to what? The angle between both the velocities. Okay, because if the position is changing by theta, right? அப்படியே அந்த tangents ஓட orientation also will change by the same angle. And initially tangent எப்படி இருக்கும்? It will be like இங்க பார்த்தா it will be like vertical. நம்ம position theta which change பண்ணா the tangent ஓட orientation also will change by theta. இப்போ பாருங்க, the velocities, right, are having an angle theta between them. Both the velocities are having an angle what? Theta between them. இப்போ என்னன்னா, we are going to look at what is the change in velocity. And we are going to look at what is the change in velocity. Change in velocity and sonna, this is what? Velocity is a vector quantity. இது எப்படி தெரியுமா? Like a bar minus b bar மாதிரி. ஞாபகம் இருக்கா? In vectors we talked about it. If you have two vectors a bar and b bar with angle theta between them, what is a bar minus b bar oda magnitude? What is it? Root of a square plus b square minus 2ab cos theta. அதுதானா? இங்க பாருங்க, அந்த மாதிரி the v1 bar minus v2 bar அதோட magnitude எவ்வளவு பாருங்க? root of, ஏன்னா values are same for both of them. இங்க என்னது v square வரும், திருப்பி v square வரும், minus 2 into v cos theta. Okay வா? So this is what the change in the velocity. Okay, அடுத்த ஸ்டெப் என்னன்னா, we are going to simplify this. அப்படியே அந்த எக்ஸ்பிரஷன் நம்ம சிம்பிளிஃபை பண்ண போறோம். ஓகே, ஸோ அந்த ரூட் கோட்ல என்ன இருக்குன்னு பாருங்க. வாட் இஸ் தேர் இன்சைட் த ரூட்? இது என்னது? 2v ஸ்கொயரா? அடுத்தது என்னது? 2v ஸ்கொயர் இன்டூ காஸ் தீட்டா. இப்போ பாருங்க, நம்ம இங்க எழுதலாம். வாட் இஸ் இட்? மாடுலஸ் ஆஃப் v1 minus v2 is equal to what? அப்படியே அந்த 2v ஸ்கொயர் நம்ம வெளியே எடுத்துட்டு வரலாம். இட் வில் பி வாட்? ரூட் 2 இன்டூ v ஆயிடும். 1 minus cos theta. இங்க என்ன தெரியுமா? we will use one more trigonometric identity. 1 minus cos theta, இதெல்லாம் நம்ம basic mathematicsல வரும். 1 minus cos theta will be 2 cos square theta by 2. 2 cos square theta இல்ல 2 sin square theta. ஃபார்முலா என்ன பாருங்க? 1 minus, what is the formula for 1 minus cos theta? Again, what is the formula? 1 minus cos theta, right, will be equal to what? 2 sin square theta by 2. Okay, so like we have this 1 minus cos 2 theta, right, that will be equal to what? 2 sin square theta. 1 minus cos square is equal to what? 2 sin square theta. அப்படியே நம்ம 2 theta க்கு பதிலா theta வச்சு replace பண்ணா it will be what? 1 minus cos theta will be equal to what? 2 sin square theta by 2. Okay. So அந்த ரிசல்ட் அப்படியே நம்ம யூஸ் பண்ண என்ன வரும் பாருங்க, root 2v. இந்த ரூட் குள்ள என்ன இருக்கும்? 2 sin square theta by 2. ஓகேவா? திருப்பி இங்க root 2 வரும். So root 2 into v into root 2 into sin of theta by 2. இங்க பாருங்க, what is it? Root 2 into root 2 2 ஆயிடும். So that is the 2v sin of theta by 2. Is that change in the velocity? This is the change in velocity. Okay va? So அடுத்த step பாருங்க, we are saying that the angular displacement theta is a small value. Angular displacement theta is a small value. Small and sonna what is it? If theta is small, right? Appo enna agum? The sine of the angle can be equal to what? Almost that angle value. So if theta is very small, right, that sine of that angle will be equal to almost what? The angle value itself. Appo enna the paranga, what is it? 2 into v into theta by 2, and the 2 cancel aidum. Okay va? So this is what? V into theta. This is the what is this? The change in the velocity. So acceleration responsible for this, and then that is what is the centripetal acceleration, right? What is it? Change in that velocity divided by the time. So paranga, change in velocity means what? V into theta divided by the time. Now paranga, what is the theta by time means? The angular displacement by the time taken. What is it? Omega dana. What is theta by t means? It is what? Omega. So the acceleration responsible for the change in direction of motion of particle, that is what we are calling as the centripetal acceleration. Adoda value enadhu paranga, v into omega. What is the value of the centripetal acceleration? V into omega. If anything, we can use the other conversion. So if namak AC oda value vanadhu, what is the centripetal acceleration? V into omega. So if omega badala nama enna use pannala? V by r. Omega is what? The angular velocity, right? Angular velocity omega is equal to the linear velocity divided by r. Enna v is equal to r omega dana. So what is it paranga? V square by r and solala, or we can say v omega. Ingon idona replace pannala paranga. V ku badala we can write r omega. So apdi nama replace panna, what is it? R omega into omega. That will be what? R into omega squared. This is the first expression. Then is second expression, third expression. So centripetal acceleration of the value, right, will be equal to what? V omega and solla, or we can say it as what? V square by r, or we can say it is what? R omega square. So this is the centripetal acceleration of the derivation. So we taken that the particle is going in a circular motion. Again we have said that the direction is changing by a small value theta. Theta nama small edukrom. Okay, for the small change in the position, the angle that gets developed between the velocities is what? Theta. Adhu theta da. And if the angle position is changing by theta means the tangents also will shift by the same angle theta. The direction of motion will be along the tangent line, right? Adanala the angle between both the initial velocity or value and final velocity is what? Theta. Upon we have taken the change in the velocity using the vector concept, a bar minus b bar. What is a bar minus b bar? The magnitude root of a square plus b square minus 2ab cos theta. Angle we simplified it. Simplify pannittu we have got what is the change in velocity expression. Finally enna varudhu? That is coming as what? V into theta. Ella simplify pannadukku appuram the change in velocity divided by the time taken. Okay, so time which nama divide panna adulende we are getting what? The acceleration which is responsible for the change in the direction of motion. Inga we assume that the velocity of the magnitude is same. And we have taken it to be v in both the cases. The two cases we taken it as what? V only. Very on the direction mattum change agara madri. Okay va? So the acceleration that is responsible for this is what? Centripetal acceleration dana. So what is the value coming as? And the change in velocity value which is v into theta. Appadi nama time which divide panna, that is giving us what? V into omega. already நமக்கு ரிலேஷன்ஸ் இருக்கா omega and v. What is it? V is equal to r omega or omega is equal to v by r. அந்த ரிலேஷன்ஸ் வச்சு நம்ம சிம்பிளிஃபை பண்ணா we will get three forms வரும். Centripetal acceleration value either v into omega அப்படி நம்ம எக்ஸ்பிரஸ் பண்ணலாம், or we can write it like what? v square by r. இதுதான் நம்ம மெயினா யூஸ் பண்றது, like in all our என்னது the work energy theorem or the Newton's law of motion. அங்கெல்லாம் என்னது we have used this one. Why? Because we have not talked about the angular velocity concept there. Okay, அதனால we were using centripetal acceleration சொன்ன உடனே we were using which formula? v square by r. So இப்படி தான் அந்த ஃபார்முலா வருது. ஓகேவா? Or we have one more third formula for that. What is it? r into omega square. What is the third formula for that? r into omega square. ஓகேவா? So this is what is the centripetal acceleration or derivation. அடுத்த கான்செப்ட் பாருங்க, like the way for a particle which is in linear motion. So particle linear motion என்ன வெச்சுக்கோங்க, we talked about the linear momentum. So linear momentum ன்னு சொன்னா what is it? That is represented by the symbol p. What is it? Mass of the particle times அதோட velocity. It is a vector quantity. அது it's a vector quantity. அந்த மாதிரி இங்க என்ன தெரியுமா, when a particle is in angular motion or more specific சொல்றதுக்கு என்ன circular motion. But when there is an angular motion, we will try to define a momentum which is going to be called as an angular momentum. It is represented by the symbol L. We will represent the angular momentum by which symbol? L. Angular momentum of a particle, right, is always defined with respect to an axis or a reference point. This is very important. And the angular momentum sonna, we should always define this with respect to ஏதாவது ஒரு ஆக்சிஸ், அதை நம்ம ரெஃபரன்ஸா எடுத்துட்டு இல்லைன்னா ஒரு பாயிண்ட் ரெஃபரன்ஸா எடுத்துட்டு அந்த பேஸ் பண்ணி தான் we will be able to define the angular momentum. ஏன் தெரியுமா? பிகாஸ் இங்க பாருங்க, we are having a particle, அதோட மாஸ் m, velocity v, it is going in a direction. So அந்த பார்ட்டிகளோட linear momentum நமக்கு தெரியும், what is it? Mass times velocity. So இங்க பாருங்க, this is the reference point we taken, or the z axis is the reference axis. The reference point and the origin. The z-axis is what? The reference axis. The position vector of that particular location, and the point or location is the position vector is r bar. What is r bar? Position vector. Position vector is what is it? The reference point we have to draw a line to the location of the point. That's the position vector. Okay. So angular momentum எப்படி தெரியுமா நம்ம டிஃபைன் பண்ண போறது? It is defined as the cross product between r bar and p bar. Cross product ன்னு சொன்னா the order is also important. ஏன் தெரியுமா? a cross b is not equal to b cross a. அதனால நீங்க கரெக்ட்டா ஞாபகம் வச்சுக்கோங்க. What is it? It will be r cross p. p cross r கிடையாது. What is it? It will be r cross p. ஓகேவா? So r bar is what? Position vector of the particle location. Cross product with p bar. P bar means what? The angular, sorry, p bar means what? The linear momentum. Okay, so இப்ப பாருங்க, this is a cross product, right? So அதோட magnitude எவ்வளவு? What will be the magnitude? R into mv into sin theta தானா? What is the magnitude? It will be what? Because if you are looking at two vectors a and b, cross product means what? A cross b means what? What is the magnitude? A into b into sin theta தானா? So it will be what? R into mv into sin theta. So we can rearrange them. Rearrange பண்ணிட்டு we can write it like this. பாருங்க, mvr into sin theta. ஏன்னா இந்த mvr expression, right, I'm sure you would have seen before, like now angular momentum. அதை நம்ம அடுத்த ஸ்டெப்ல பார்க்க போறோம். For a particle going in a circular path, right, what is the angular momentum value? We'll see mvr தானா? So அது அடுத்த calculation வர போறது. ஓகேவா? So if the r bar and p bar are at some angle, right, அது வெச்சு we will be able to calculate what is the angular momentum. So angular momentum சொன்னா always that is based upon a reference axis or a reference point. On the basis தான் we will be able to calculate the, ஏன்னா we have to represent the position vector from the reference axis or the reference point. On the basis தான் we will be able to calculate the angular momentum. Okay, இப்போ குயிக்கா ஒரு क्वेश्चन கேக்குறா, does the angular momentum depend upon the reference? யோசிச்சு பாருங்க, linear momentum சொன்னா that is absolute value. Okay, அங்கேயும் நம்ம absolute சொல்லக்கூடாது. ஏன் தெரியுமா? Linear momentum is related to what? Velocity, and velocity will depend upon who is the observer, because velocity is what? It is going to depend upon the observer. Okay, but again kandipa it will not depend upon the reference point. But angular momentum அப்படி கிடையாது. இப்போ நம்ம origin இங்க எடுத்து வெச்சுக்கோங்க, we will get one value for the angular momentum. இங்கெல்லாம் we take the origin here. இப்போ நம்ம origin இங்க எடுத்தா what is the r bar going to be? R bar இப்படி தான் வரும், அது நம்ம r dash ன்னு சொல்லலாம். So angular momentum value will be changing. So angular momentum value, this can be some theoretical questions. Angular momentum value, right, will depend upon what is the reference we choose, reference point and சொல்லலாம், or the reference axis. Okay va? So this is about the concept of angular momentum. Angular momentum is what? It's not a scalar. என்ன பாருங்க, it is defined as the cross product, right? So it is a vector quantity. So L bar ன்னு represent பண்ணலாம். How do we give the direction of it? Right hand thumb rule தானா? So R, we have to take a cross. So right hand thumb rule, right? A cross B direction எப்படி? We have to take a cross product of R bar with V bar or P bar. ஏன்னா P bar will be in the same direction of V bar, because P is equal to what? MV தானா? So we have to take a cross product of R with P vector. அது எடுத்தா we will be able to get what? The direction by using the right hand thumb rule. இங்க பாருங்க. So in this representation, right, நீங்க R cross P பண்ணா the thumb will be what? Pointing along the Z axis. Thumb எப்படி? Thumb will be pointing along the Z axis. Okay va? So this is how we will be able to calculate the angular momentum of a particle with respect to an axis or a reference. So more important point என்னன்னா, angular momentum will be depending upon what is the reference we are choosing or what is the reference axis. அடுத்து பாருங்க, this is what we are talking about, the angular momentum of a particle which is in circular motion. இங்க பாருங்க, circular motion இருந்தா what is the change going to be? மத்ததெல்லாம் அப்படிதான் இருக்கும். What is the change going to be? The angle theta between R bar and P bar, அதோட வேல்யூ என்ன? Will be 90. ஏன்னா R bar will be what? So here we are choosing the reference line or reference axis ன்னு சொல்லலாம், that is going through the center of the circle. இது பாருங்க, R bar will be the radial direction வரும், V bar எப்படி? Always tangential தானா? So angle between them is what? 90. அந்த ரெண்டு ரெண்டுல what is the angle between them? 90. So இப்போ பாருங்க, what is it? ஆல்ரெடி நம்ம கிட்ட ஃபார்முலா இருக்கா? What is it? MVR into sin theta. இதுதானா? Theta 90 means what is it? MVR. Okay, what is it? பாருங்க, what is it? If you have the angular momentum L, which is MVR sin theta, theta அப்படியே நம்ம 90 வச்சு replace பண்ணா what is sin 90? Sin 90 is what? 1, right? So L will be equal to what? MVR. This is what we use as the angular momentum of a particle which is in circular motion. இதுதானா? So இங்க பாருங்க, what will be the direction of the angular motion? Always அப்படிதான், like we have to give it by using the right hand thumb rule, R cross P. அதோட right hand thumb rule property base பண்ணி we will have to give the angular momentum அதோட direction. இங்க பாருங்க, when we are giving the angular momentum direction, right, இங்க ஒரு இது வரும், என்ன தெரியுமா? The direction of the angular momentum will be perpendicular to the plane of the, it will be what? Perpendicular to the plane of the circle. என்னது பாருங்க, the direction of the angular momentum, right, it will be what? Perpendicular to the plane of the circle. Okay va? So this is about the direction of the angular momentum. So inga enna, we have one more relation, the relation between the angle or the relation between L bar and omega bar. Adanna we will talk about it when we discuss about the rotational motion of a rigid body. And the context we will talk about it. Okay, நம்ம அந்த ரிசல்ட் பார்க்கிறது கிடையாது. We'll talk about it when we talk about the rotational motion of the rigid body. அங்க என்ன, we'll talk about what is the exact relation between L and omega. So நீங்க இங்க பார்க்கல, இந்த டயக்ராம் என்ன, we are showing L bar and omega bar in the same direction. அதுதான் the relation. L bar and omega bar, right, will be in the same direction. அது எப்படி வருதுன்னு சொல்லிட்டு we'll talk about it when we go to the rotational motion of a rigid body. அந்த discussionல we'll talk about it. ஓகேவா? So this is how we will be able to give the direction of the angular momentum. General angular motion context la what is the angular momentum of the formula? R cross P. Particularly in case of circular motion of a particle la, it will be what? And theta will be 90, right? So adanala angular momentum will be what? mvr. Okay va? So this is about the idea of the angular motion. Next class we'll talk about the motion of a rigid body. So when we talk about the motion of a rigid body, we are going to focus on the rotation motion of a rigid body and the rotation plus translation. Again, we will take an example of that which is called as a rolling and solid. Okay, so that's our purview. What is the thing that is there in our syllabus? One is the full rotation of a rigid body, the rolling of the rigid body. Okay, so and solid we will be able to see it in the next class. Okay, so keep practicing questions. This is a very important chapter for the NEET examination. You practice panna, you will be able to get more confident in solving problems. Okay va? We'll see in the next class.